Okay, so for number 1, regulatory proteins are the activator, repressor, and the cap protein. For part B, small effector molecules are inducers, inhibitors, allolactose, and cyclic AMP. For C, DNA sequences are +1, -10, operator, and LAC-A and LAC-Z. Part D, we were confused by, we weren't sure if it meant what were actually parts of the LAC operon structure or what interacted with it. But we have inhibitor, allolactose, cyclic AMP, and inducers, just because those are molecules that would bind to something that bound to the operon, not to the operon itself. And for part E, structural genes are LAC-Z and LAC-A.
Okay, and then for number 2, it asks the LAC operon is regulated by 2 inducers, and we said allolactose and yeah. And then for B, the binding site for the factor and RNA polymerase is called LAC-E, while the cap site is the binding site for the activator that regulates the LAC operon. For C, we said the enzyme adenyl cyclase converts ATP into pAMP, and then the -35, -10, and +1 sequences are found within the LAC promoter portion of the LAC operon. And then for E, the LAC-L gene encodes the LAC repressor, while the LAC-Y gene encodes lactose amylase. And then the next one, attenuation, can regulate gene expression in bacteria by causing transcription to terminate prematurely. And then the last one is E. coli strain that contains 2 copies of the LAC operon is called a merozygote strain.
All right. For number 3, there's no blue color produced because transcription doesn't occur. For part B, because glucose is absent, there is a high rate of transcription, and so blue is present. Part C, there is no blue because the X-gal is absent. For part D, there still is blue, but because glucose is present, there's not as much, not as high a rate of transcription as in part B. And part E, X-gal is again absent, so there's no blue color produced.
For question 4, all of the components of the LAC operon are in their wild type, so it is inducible. For B, the IF is a LAC repressor that can bind to the operator but cannot bind to allolactose. So it will never be released, so it is non-inducible. For C, it is constitutive because the operator site is defective, so it can't actually bind to the LAC repressor. For D, it is inducible, and the reason for that is because the chromosome has all the normal components of the LAC operon. E is constitutive. That's because once again, the operator site is defective. And moving on to question 5. When lactose is present, so for part A, when lactose is present and the promoter site is defective, it can't start in either case. So for part A, it's 0 with lactose present and 0 with lactose absent. Part B, the operator is always operator side is always not occupied, and so it's always going. So that's one for when lactose is present, and one when it's not. For C, we have two copies of it can be made because both the chromosome and the plasmid are operating properly. When lactose is not present, the only one that will keep going is the one with the defective operator site. So for C, it's 2, 1. For D, it is 1, 1, because both the plasmid and the chromosome make up for the defective components of the other. And for E, it's also the same situation where the different defective parts of the chromosome make up for the defective parts of the plasmid and vice versa. So we have 1, 1 there also.